Alright, picture this. A massive family of stars, planets, and moons all hanging out together. Now, exoplanets, planets outside our solar system in the Milky Way, they've got scientists really curious. Believe it or not, some of these exoplanets are weirdly similar to Earth. Like twin planets similar. Take Proxima b, for example, a mere 4.2 light-years away. The James Webb Space Telescope is on the case, trying to figure out what's going on there. Think about it. The Milky Way could have a quadrillion exoplanets. That's a 1 with 15 zeros. If each planet was a grain of sand, we could fill the Grand Canyon twice. Crazy, right? And get this, around 20% of these planets might be Earth-like with similar land and air. That's a 1 in 5 chance of finding our planet's twin. Plus, there could be another quadrillion moons orbiting those planets. If you're looking for life, the universe is full of possibilities. So, now that we've got the scale down, let's talk about the James Webb Space Telescope. This thing is like a superpowered detective with next-level lenses, way better than even the best telescopes out there. We're talking mirrors that are 6.5 meters wide, almost 3 times the size of Hubble's. Can spot tiny details, even a spark from a star billions of light-years away. It can also check out the tiny things about planets orbiting those stars. What makes it so special is that it doesn't just see stuff. It has sensors and spectrographs. These tools can study light to figure out what a planet's air is made of, how dense it is, and even its mass. Like a space scientist, it can tell if a planet has water, carbon, or even oxygen. It's a total upgrade from Hubble. Now, let's zero in on Proxima b. Since we found it in 2016, scientists have been all over it. Why? Well, first off, it's close, just 4.2 light-years away. At light speed, you'd be there in just over 4 years. That's a big deal when the universe is 93 billion light-years across. Finding a planet that close is like finding a diamond in a mountain of rocks. Could even give us clues about life itself. It's not just the distance that makes it interesting. Could be another Earth. Proxima b sits in the habitable zone of its star, where it's not crazy hot or freezing, so water could exist. We're talking streams, lakes, maybe even oceans like the Mariana Trench. But hold up before you pack your bags. A day on Proxima b lasts 11 Earth days. Talk about sunrises that drag on forever. It messes with the weather and living conditions. How would we deal with days that long? Would we be eating all day? Would we sleep the same way? Life would be both similar and totally weird. It's like nature is teasing us. How do we learn about a place we've never been? The James Webb Space Telescope is our best bet. It's a lab in space. Those space experts don't just spot planets. They examine them with science tools that make crime scene labs look basic. Using spectrographs, the Webb telescope looks at light from those planets. Each element in a planet's atmosphere soaks up or throws out light at a certain rate. By checking those patterns, a scientist can do a space checkup, figuring out the pressure and if there's water, carbon, or oxygen. Space science is next level. Cosmologists don't just sit around waiting for answers. They go looking for them, checking the atoms and molecules that planets are made of. The Webb telescope isn't just an eye in the sky. It's a lab and detective all in one. But here's the twist. Like something out of a sci-fi flick, scientists using the James Webb Space Telescope picked up something odd coming from Proxima b. An electromagnetic burst so complex it almost seemed like it came from civilization. The world held its breath, wondering if we were about to find out we're not alone. But then it disappeared, leaving behind a ton of questions. Was it just a weird space thing? Or was it on purpose? Maybe it was a message. That signal left a cloud of mystery hanging over Proxima b. But the story doesn't end there. Some researchers are now using the James Webb Space Telescope to look for city lights on distant planets. Imagine seeing alien cities glowing in the dark. This hunt goes beyond Proxima b, pushed forward by better tech and the simple urge to know our place in everything. The finding of various exoplanets with possible conditions has been spotted. Tools like the James Webb Space Telescope help examine these distant worlds. One cool route being taken is checking for biosignatures, gases like methane or carbon dioxide that could mean life exists. The JWST can measure the air of exoplanets and offer information facts about their atmosphere. Proxima b leads us into the future of space search. Space telescopes aid us in learning about distant planets, and the search for life past Earth got more eyes on it. The tech and measuring planets' air tell us about holding life. This search goes beyond what we know and pushes us to test different possible conditions. To find life elsewhere can deeply hit Earthlings. It affects how we perceive ourselves and changes how we perceive life and the universe. What if life grew from someplace extremely different than Earth? Could there be life in places scientists said to be impossible to hold life? With so many options, Proxima b guides us in our search. As we're getting data from the exoplanet, we're also adding knowledge to the universe, boosting the tools and ideas to discover other lives. One of the high points would be to measure the signs for life through bio or tech, which would prove life exists. Scientists still are taking it slow about finding news and answers from the signal that came from Proxima b. Looking at other clues to see the tech like alien buildings could change how we see things entirely. The idea to see cities or structures from a planet opens new doors. Teaming up space with exploration allows new options. This search has teamwork going, and as tech evolves, our skill to check the universe at a better rate also changes. The discovery of a spot in space that links many living organisms goes beyond the idea of one space for one living being. As we collect clues from lights to elements make us come closer to find our place in space. Before you pack your bags to visit Proxima b, keep in mind that day lasting 11 Earth days can mess up the chance of being there. We might ask, how will these changes affect our ability to live there? Would we eat 4 times daily? Will we sleep different? These questions get us close to the idea if we understand what helps hold living organisms. With the James Webb Space Telescope acting as our Swiss Army knife, with us checking and asking questions, we can get closer to what we assume and can give reasons for what we believe. Things can change, and that's what makes it. The story can also alter itself, and with a message coming out that looks like an answer, makes us question what we know. The signal might not have a point, but it makes us question what we know. The mystery might get more questions to be asked, and it keeps people guessing. Is it a small event? Or is it attached to something bigger? Some ideas coming to the table involves using the James Webb Space Telescope to night goggles. Can glowing lights be spotted? Can we see our neighbors show light they made? Technology and a need to our spot on the map pushes us to find places that hold organisms. Tech and space exploration help us find places on other planets. The need for bioclues helps with that hunt too. But hold on. A day on Proxima b is 11 Earth days. Imagine sunrises that just hang in there. Peaceful and all, but it messes with the weather and general living. A weird amount of day and less sunset. Would we eat breakfast every 11 days? Would we sleep as much? It's a mix of the same and the strange. Think of it like nature is messing with us, testing if we understand what makes a planet livable. How do we get information about a place we've never been? The James Webb Space Telescope is like a big lab we shot into space. It not only spots the planets around other stars, but also takes a very, very close look using scientific tools that put crime scene labs to shame. When using spectrographs, the Webb telescope reviews light from these far-off places. Those frequencies helps tell whether light in certain areas is being bounced or soaked in by the atmosphere. By studying the patterns, a scientist can take a planetary health chart. It also reveals the element or substance composition is made of. With all that information, it is another level, helping measure air makeup, detect water, and find possible carbon or oxygen. Space scientists don't just wait for clues. They go out there and dig to check those tiny atoms and compounds that make up new worlds. It's all about changing what we think about other planets using these solid facts that either breaks a theory or build new questions. Just when you think our story is over, enter the twist. Almost like a sci-fi film, scientists using the James Webb Space Telescope detected something weird. An electromagnetic signal seemingly complex by perhaps a far-out civilization. The world took pause. Is it possible we are not alone? But then shortly after the electromagnetic signal went away, it left behind only questions, theories, and mystery. Was it nothing? Was it a form of advanced communication being sent? This one event gave Proxima b a sense of mystery. Continuing that trail, researchers from Harvard are using the James Webb Space Telescope in another means. They're using it like night vision. They're now trying to find light on other planets, such as buildings and cities. If you were able to see something, imagine it. An exoplanet with life sending light into space? With new tech and a will to learn if there is another world, the search for Proxima b has now increased to far more. Tech and space research has now helped search for better places to live. Tools such as the James Webb Space Telescope can now locate and research new homes. One very cool method in progress is finding biosignatures. These biosignatures happen because life might just exist on planets.